Okay guys, welcome to AS Physics Revision question number 14 of whatever paper this was first on. Question 14 consists of, when oil floats on water, coloured interference patterns are often seen. The interference patterns are formed because of the thin film of oil. A thin film of oil can also produce interference patterns with monochromatic light. The diagram shows light from a monochromatic source incident on a film of oil. Explain why interference patterns may be seen. Okay, so I'm going to currently highlight some things in the question that might seem of importance. Let's use a red. Okay, so I'm just going to highlight, actually no, I'm going to cross out all the stuff that's sort of useless, sorry. Yeah, all we need to do is worry about this bad boy here. We need to explain why interference patterns may be seen. And if we go to my other photo, if I can do this whilst recording. Yeah, get rid of that. Yeah, get rid of that. Nice one. Let me just add this bad boy I drew up earlier in true Blue Peter style. Here we go. Okay, I can't zoom in and do that bad. Okay, here we go. So here's the mark scheme. Like I said, let me highlight in, I don't know, maybe a nice green. Here we go. This stuff, question 14, blah, 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 blah. Not useful. This stuff, look, five marks available for this question. Your first mark is going to tell the marker that there are two different waves, which are highlighted here, 1 and 2. That's your first mark, done. Second mark, tell the examiner, the marker, that they're the same frequency and that they are therefore coherent. That's important, because that will then lead you on to your next point, which will literally, as I've written, upon meeting, they will superpose constructively or destructively depending on their path difference. Now that sentence alone got me 2 marks. Two marks of the possible 5. And there is a, hang on, I think these two link together to give you 1 mark, but oh well. This is how it's going to work. So you need to say that they superpose. Sorry, I've crossed it out. That they superpose, which means the waves meet either con or destructively. I should probably use a different color now. Use a nice, yeah. Con or destructively, which depends on their path difference. There being a different path difference is quite important. But yeah, then that will lead you on to this point here, which says, if it's a wavelength of difference out in phase, it's going to be constructive superposition. Or if they're half a difference out, destructive interference is antiphase. Now what I forgot to put on here was like a lot of therefores. So if I can get rid of this, delete drawing, delete the photos. Here we go, let's get this bad boy on the roll. Okay, so we need just a therefore little wrapping up thing. If they are a wavelength, they are in phase. If they're half a wavelength over 2, is equal to out of phase. Okay, is that clear? Alright, I sounded a little bit patronizing there, I'm sorry. Yeah, so then this will bring us on to, therefore, patterns, sorry, this is completely freehand. Patterns are made much like a diffraction grating. Thank you guys, I've been Mitch. Miss Taylor will probably tell me to re-record this, but oh well, it was worth a shot. 4.5 minutes going on YouTube. It will take like 4 hours with the school's Wi-Fi to load up. Happy AS Physics. And I've been, hey, it's Mitch, lol. Lol.
Made with Doodlecast Pro.